All right, Algebra 2 skills number 9, solve by combination factoring. So sometimes you have to do several things when you factor. So we'll start by the concept of the greatest common factor, or GCF. And here's an example of a GCF. If you know or sense that factoring may be used, but it's not a clear pattern, look for a common factor in all your terms. So here, 6x minus 12, clearly a 6 goes into both of those. So what you do is basically you undistribute. You take a 6 out and then divide 6x by 6 is x. Negative 12 divided by 6 is negative 2. And at this point, we should be able to recognize that 6 is the largest thing that goes into 6 and 12. But to check that you've correctly taken out the GCF, as we've said in the previous video, make sure that if you distribute, it goes back to your original, and make sure also that in the parentheses there's nothing in common other than a 1. So another example, sometimes you can take a variable out. So in this case, 1 and 9, there's nothing bigger than 1 that goes into that. But I can take an x out. So notice again, if I distribute the x, it goes back to this. And notice also that now the x and 9 have nothing in common. So you're looking for both a number and a variable for a GCF. You may have one or the other, or you may have both, like this example. And also notice that it's not always the first number that automatically comes out. Here, the largest number that goes into 8 and 12 would be 4. Common mistake is to think the 8 always comes out, but not in this case. It's a 4, and also you have one x there. A little tricky, you have x cubed, so be careful. There's still 2 x's left here. If I divide 8x to the third by 4x, I get 2x to the second. 12x divided by 4x is 3. Okay, again, if I distribute that back, I get my original, and there's nothing in common here. There's no more x's, and then 2 and 3 have nothing in common. So using the zero product property, as we've said in previous videos, if we have two things that multiply together to give you 0, then that only is going to be true if one of those two factors is 0. You can't have an equals 0 with a product with two non-zero values. So we know something's got to be 0. The first example here, again, this doesn't look like a clear pattern, but you get a sense that factoring can be used, and in fact you can take an x out. So if you do that, that sets up our zero product property. We have an equals 0, we have now multiplication. We didn't have it here, we only had an add between, but now we have a multiply between. So we know that either x is 0 or x plus 7 is 0, and then that makes an easy solve there. You subtract 7 to get x equals negative 7. This one was already solved. And sometimes again you see that solution set. The braces and the solutions put in ascending order. A second example, now you don't have a 0 here, so let's subtract the 9x to get that 0. And let's look for the GCF, which is 3x. Again, check to make sure it distributes back, make sure that this is clean. So we're going to set each piece equal to 0. This one's simple, you just divide by 3. This one's a little more difficult, but being Algebra 2, we're not going to show every step. You add 3, divide by 2, so x equals 0, x equals 3 halves. And we're not going to put the solution set there. Third and final example is a little bit different. Sometimes it looks like it may be one of those harder trinomials because you have the 6. But if you look carefully, all three terms are divisible by 6. So often it's to your advantage to go and take that 6 out. And notice here that now it's an easier trinomial. We have a leading coefficient of 1 here. And that's particularly nice because we have this equals 0. So I can divide both sides by 6. And in so doing, it's almost like the 6 just disappeared. It didn't. What happened was 0 divided by 6 is just still 0. And on the left-hand side, it goes away. But now I have a much easier problem. And now it's just simply what are two numbers that multiply to 2 but add to 3. That's 2 and 1. Again, set them equal to 0, which I didn't actually even show that step here. It would be x equals negative 2 or x equals negative 1 for your two solutions.